Okay, as we move on to topic 2.3, the title is Another Look at Linear Graphs. And some of the things I like to go over is things we've already covered, standard form, slope-intercept form in the standard way. And then here is the functional notation of slope-intercept form, where we substitute the y with f of x, which is function notation. Then slope. And then these are two new equations we're introducing today. They're both in standard form for what they are. And that is here where y equals b. And you may recall that b is the y-intercept. And here they're saying it's a horizontal line going through the y-intercept. So whatever b is, when you have an equation y equals b, it's just a horizontal line going through b. And I've also put there the slope of a horizontal line is 0. That is, if you took 2 points along that line, plugged it into this equation, you would end up with the top part being 0 and the bottom part being, let's say, 3. And we had said anything 0 divided by any real number other than 0 is 0. So that's what this would look like. And we did some of that in our previous section. Here, this is another equation in the standard form for what's here. X equals A. And A happens to be the, you might recall, the x-intercept. So it's where on the x-axis this equation will cross. And again, it's a straight line, but it's a vertical line. And if you did the slope of this by taking 2 points, you would end up with something like, let's say, -2 over 0. So when something is divided by 0, you get that the slope, in this case, is undefined. Anything divided by 0 is undefined. And these are just two other sort of hints as opposed to formula. This is if you find the slope of one equation and it equals the slope of the other equation, that is, the slopes are the same, but the y-intercepts, the b part, are different, then the lines are parallel lines. And this is how we write it. So this is sort of a summary for lines that are parallel. Slopes are the same, y-intercepts are different, the lines are parallel. And we'll be doing some examples on this shortly. Now in example 8, or hint 8, we're saying if you have a slope of one equation and you multiply it by the slope of the other equation, and the product of these slopes is a -1, such as if the slope of one equation was a -1/2 and the other one was 2 over 1 or 2, everything cancels out and this is a -1. So we say it's sort of the reciprocal, but the negative reciprocal. So the negative reciprocal of 2 would be a -1/2. And the product of that would be a -1. Then these lines are perpendicular. That's what this refers to. Now, another thing we'll be looking at as we do this section is something I gave in a previous lesson, and I'll just review it here. We said there was a special T-chart that's very useful. And I call this T-chart the X and Y intercept T-chart. So if you make a T-chart, put a 0 there for X and a 0 there for Y, And then if it's in standard form, it's very easy to use, and I'll show you one of those later. Then you're going to get a value here that's going to be b. And this happens to be the y-intercept. And if you do y is 0, you're going to get a value for here. That'll be a. And that happens to be the x-intercept. And you might recall these are the formal ways of writing the y-intercept and the x-intercept. So we'll be reviewing that as we go on. So let's start with our examples. For example 7 through 10, they want you to find the slope, that is m. So here we're going to solve the equation for y. Y equals, and we're going to transpose the 6, it becomes a negative 6. So this is y equals 2. In fact, let's solve all the equations first. And then here we want to solve for a positive x, so we put x over to this side. This goes over to this side as a negative 15. So this becomes a negative 8. And here we're going to subtract 5y from both sides, and we get x equals negative 9. And here we're going to move the negative 2y to this side, and that gives us a positive 2y. Transpose this gives me a negative 11. Divide both sides by 2, and I get y equals a negative 11/2. So we've solved all the equations for either y or x. And the equations then we're talking about are equation 5 and equation 6. And any equation that ends up with the form of y equals the y-intercept, y equals the y-intercept, the slope is going to be 0. And we've defined that there. Here x equals a negative 8. That's this equation. The slope is undefined. Here x equals something. The slope is undefined. And this is y equals something. The slope is 0. So once again, being familiar with these forms, standard forms of the horizontal line or the vertical line, horizontal is y equals b, that's the y-intercept. X equals a, that's the x-intercept. And once you've determined that's what you have, then you can just use your chart. All horizontal lines, the slope is 0. All vertical lines, the slope is undefined. Going on to number 11, here they're asking us to graph, and in your little booklets you do have graph paper. So y equals a negative 2. This is formula 5, horizontal line through negative 2, and that's the graph. X equals negative 4, positive 4, vertical line through 4. Now for number 13, we have to find out what y equals. We divide both sides by 5, and we get y equals negative 2. And there we are. So again, knowing the standard form for a horizontal line and a vertical line, and then knowing that this is the y-intercept and that's the x-intercept, makes your graphing of these, I think, rather easy. And the proof of the pudding will be on your practice and quiz me, and then later the test. For number 15, here we're going to use our special t-chart, because the instructions are find the x and y intercepts and graph. So again, if x is 0, y will be a -2. If y is 0, x is going to be a +2. And then to graph that, there's your -2, there's your +2, and there's the graphs. We have used that special t-chart, the x and y intercept t-chart, to find our x and y intercepts. Plot them, and there's your 2 points. Now, for number 16, even though they said find the x and y intercepts, I think it's okay if we use the technique we used previously. That is, solve for y, which is what the equation is, then plot the y-intercept that we know. If x is 0, then it's going to be a -6. So 1, 2, 3, 4, 5, 6, a dot right there. Now our slope is 3/1. So using that technique, we're going to go over 1, up 3, and then this gives us our line. So our x-intercept is right there. We don't know what it is, but this is a valid way. But let's find the x-intercept anyway. So now we're saying that y is 0. So we put a 0 there. And we transpose that, and that becomes a 0 equals 3x minus 6. I guess I could have brought that 6 over here. There we go. Divide both sides by 3. I get x equals 2. So my y-intercept, or my x-intercept now will be 2. And again, I didn't make that graph very well, but that's what it's like here. Okay? So, again, there's a little wiggle room here. Even though they asked us to solve for the x and y intercepts, make the t-chart if it's in standard form. If it's in slope-intercept form, you can use that other method, or you can use it and find out what it is. Number 17, again, the t-chart would work very well for that. There's our special x and y intercept t-chart. Now if x is 0, this is going to be a +2. If y is 0, that's going to be a -5. So if y is 0, we're going to divide both sides by 2, we get a -5. And then to graph it, 0, 2, a dot there, and then 1, 2, 3, 4, 5, a dot there. There's our graph. Now this one's in function notation. You could use the x and y t-chart, or there's your y-intercept, b, which is 1. Your slope is a +2/1. There's your slope, so I'm going to go over 1, up 2, and there's my graph. Again, there's some that we're skipping because they're not in our curriculum. In this next part, they want us to look at, without graphing these equations, to determine if these are parallel or not. And our technique is we have to look at what the slopes of the lines are. If the slopes are the same, but the y-intercepts are different, they're going to be parallel. And for all of these, it's just really comparing the slopes. So, here we know the slope of this one is a -2. And I've rewritten that so it's in standard form. Now, this one, it's going to be y equals, I have to put it in standard form, transpose this to the other side. Now that I've put this second equation in standard form of slope-intercept, put a plus there, then I see when I compare my slopes, this is a -2, this is a +2. So they're not the same slopes. So these lines are not parallel. Now for this one, again, I have to solve for a positive y so I can compare my slopes. So I'm going to put the y over there, that makes it positive. This becomes a +2, and that's an x. So the 1 in front of that x is my slope. And then here, this is a little bit in standard form, but reading it from right to left. What's my slope? It's 1. Are my slopes the same? Yes. So this is parallel. So the key to all of these is to, without graphing, you have to find the slope. You find the slope by putting it into standard form of slope-intercept. This is standard form. This is slope-intercept. So, again, once you have it in that form, you can compare your slopes. If the slopes are the same, the lines are parallel. And then in a few moments, we'll go over number 8. Okay, for 23 and 24, we're asked, again, without graphing, are these system of equations, these sets of equations, perpendicular? And the rule, once again, was if you multiply the slopes, and the product of that multiplication is a -1, that is, one is the negative reciprocal of the other, then the lines are perpendicular. But the strategy is, how do we find out the slopes? Especially if they're in standard form. Well, put them in slope-intercept form, and then compare the slopes. So that's what we're going to do. Now, this one's in function notation, but the slope is 2. So let's solve for y here. So we're going to get 2y, bring the x over to this side as an opposite sign, transpose, -x, plus 3, divide everything by 2, and we're going to get y equals a -1/2 x plus 3/2. So our first slope is 2. Our other slope is a -1/2. When we multiply them, this becomes a -1. So that's, these equations are perpendicular. The upside down capital T, that's the symbol for something being perpendicular. Okay, now we kind of ran out of room, so I'm going to erase some of this here. There we go. I'm going to redo example 24, but but to give you some background, it's without graphing, we want to see if in fact these two equations are perpendicular. And the technique, you may recall, is hint number 8 over here, that if the slope of the first equation times the slope of the second equation equals a -1, then the lines are perpendicular. So we're not going to graph, but what technique do we know that we can find, let's say, the slope of this equation and then the slope of this equation? And the hint is in equation 2, where it's in slope-intercept form, we want to find the slope. So for this equation, we want to solve for the letter y. So we go 3y equals, I'm going to take this term, transpose it, it becomes a -x, and then the +3 stays there. So just by taking the x term to the other side of the equation, by transposing, I change its sign, and now I divide everything by 3. And I get y equals a -1/3 x plus 1. Now when I did this before, I was kind of jammed up for room, and it's really critical that you have it clearly representing what is the slope. So the slope of this equation is a -1/3. Now again, we want to solve for y. Now y is on the right, so we can go 6y equals, I'm going to transpose my 1, my -1, it becomes a 1 on this side, a +1, and then I have 2x. And now I want to solve for y, so I'm going to divide everything by 6. Now this becomes a 1, so I'll put the y here. This 2/6 becomes 1/3 x plus 1/6. So the slope now of my second equation is the numerical coefficient of the x, which is my m here, and it's 1/3. So now I'm going to compare the slopes. I have a -1/3 times 1/3, and that equals a -1/6. Does it equal a -1? And the answer is no. It equals a -1/6 when we multiply the slopes. So therefore, these equations, the lines are not perpendicular. Again, why? Because the product of the slopes does not equal a -1. Okay, in these now, they want us to find what is the slope of the original equation, and then what would be the slope of a line perpendicular to that. So as we look at this, there, it's easy to pick out the slope when it's in slope-intercept form. It's what's before the x. So this is a -3. So the line that would be perpendicular to that would be a slope that is a positive 1/3. So this one is a -3, its negative reciprocal is 1/3. If we multiply these two numbers together, that would equal a -1. Now, for this one, we have to find out what our slope is by solving for the letter y. So we have 7y equals 3x, as we transpose that, plus 2. And we divide everything by 7 now. And we get y equals 3/7 x plus 2/7. So the slope of this equation is 3/7. The slope of an equation that is perpendicular to this would be its negative reciprocal. So that slope would be its negative 7/3. And those are the answers. Again, a lot of stuff going on here, but hopefully, again, you can use your notes as your reference. Practice the quiz bees. For these two, 27 and 28, they want you to write an equation in slope-intercept form that is parallel to this, but goes through this y-intercept. And for these that are perpendicular to these and go through this y-intercept. So all we have to do here is we're going to say y, my pen's getting lighter here, a negative 2x. So the slope stays the same. We just have to change the y-intercept. And this line is now parallel, same slope, different y-intercepts. Here we have to find the slope of this line. So I'm going to solve for y. 4y on the other side becomes positive. 2x minus 5, divide by 4. I get y equals 1/2 x minus 5/4. So my new equation would have that same slope, y equals 1/2 x. That's the same slope, but now with my new y-intercept 1. Now for these that are perpendicular, I have to have the negative reciprocal of 3, which is y equals a negative 1/3 x. And then now I'm putting in my new y-intercept, which is 2. So in order for it to be perpendicular, I have to replace the original slope with its negative reciprocal. I'm redoing number 30 as well, because it was sort of jammed in, and here we can see it a lot better. Now the instructions for number 30 was to give an equation in functional form that is a line perpendicular to this equation, but with this y-intercept. Remember, the y-intercept is in the form of 0b. So anytime we have a 0 for the x-coordinate, whatever is in the y position is our y-intercept. So what we need to figure out is what's the slope of this equation. So we're going to solve it for y. 3y equals, I'm going to take this term, transpose it, negative 2x plus 7. Now I'm going to divide everything by 3 as we solve for the letter y. And we get y equals a negative 2/3 x plus 7/3. Now this was the original y-intercept. We don't really need that. All we need to look at is this slope. Now, in earlier examples, we said we wanted an equation that was parallel. If it was parallel to it, it would have to have this slope. But we want a line that's perpendicular to this equation. So we look over here again. In order for it to be perpendicular, it has to be the negative or opposite reciprocal of this number, this slope. And they want it in function notation. I was putting it in the regular notation of slope-intercept, but they want it in this form. So it would be f of x is equal to, now the reciprocal, the negative reciprocal of this would be a positive 3/2, and we add the x, and now we apply this y-intercept, which is -4. So there it is, done a little more clearly and not so jammed up. My black pen was dying on me, so I had to change to red. But what we're doing for these is to determine if these equations are linear or not linear. Now, we don't see any power to the second power, but 34 down here has a variable in the denominator. When you have a variable in the denominator like this is not linear. And for these others, they want us also to find the slope. So these equations are linear, but they want us to find the slope. So again, take your y term, bring it over to this side, it changes its sign, and you get 2x minus 3 equals 5y. Divide everything by 5, and we get y equals 2/3 x minus 3/5. And you might say, well, what's the slope? Well, whatever is in the m position, which is 2/3. Here we had to get rid of parentheses. So this is 7x minus 28 equals 2 minus 3y. So we're going to bring the 2 over to this side. That goes over as a -2. Add it, I get a -30. So I'll save some room here. Now I'm going to divide everything by a -3. And notice this ends up being a positive y. So my slope here is going to be a -7/3. In number 33, here we have a fraction. So the same rules for getting rid of fractions. Multiply everything by 3. Here we then get, remember we can change this to y. So this will become y equals 3x minus 18. So what will our slope be? R3. These are all linear. This one is not linear due to the variable being in the denominator. Again, some of this is a little more difficult than we'll have on our test, but is stuff that's in our book.